Shall I start now?
Yes, sir.
Okay. Good morning, students. I am Dr. Senthilkumar, Department of Electrical Electronics Engineering, VSP Engineering College, Karur. Today I am going to cover the topic on combinational logic design in the subject of digital circuits and design. Okay. So first we are going to talk about what is the need for digital circuit and design. It is the introduction part. Everyone aware about the computer nowadays. Okay, this is the slide. We are showing the components or parts of the computer. In that you could see there is a screen and there is a CPU. Normally, technically we call it as base unit or central processing unit. Apart from that, there is printer and there is a scanner and there is a keyboard, mouse, and for the storage purpose we are using pen drive. So in that you could see the main processing system is that CPU. Okay, it contains the processor, especially the microprocessor. Nowadays, you are familiar with the Intel processor also. These kind of processors are involved in that processing unit. So it will do the process. Okay, this is the main topic that we are going to cover in the topic that we are going to discuss. Apart from this, you could see there is a monitor. It is the input device, output device, and for the input purpose we are using keyboard and as well as mouse. Okay, so apart from the monitor as the output, you have a printer as well as the other memory devices also available. Okay, so that you can store that one. You can see that the pen drive, small red color part is there, that is called as pen drive. In that also you can store. It is also one kind of output source or drive. Now we see computer system components. In the last slide we could see the picture of the computer system. Okay, in that what are the major content in that we will see. Okay, the first one is memory. Everyone is aware about what is memory. Okay, it is one kind of storage device. It is used to store instruction. Normally we say it is a software. Okay, so the instructions in terms of software as well as it will store the data also. Okay, the data necessary to process in the software. So everything will be processed as at the central processing unit. That is the processor in which it has to process everything. And another one is, as we told, input output devices are there. Okay, as we told that input one monitor is one kind of input output device. A keyboard is one kind of input device. Okay. Now we move on to arithmetic and logic unit. Okay, it is the main unit that so sometimes it is called as processor. It is involved or put into the processor. Okay, the central processing unit. Okay, in that it has to perform arithmetic and logical operations. So that it is called as arithmetic logical unit. Okay. So next part is control unit. That is inbuilt of the motherboard. Okay, the motherboard itself we are going to place the processor. Apart from the processor, there will be the other controlling circuit that is called as control unit. With the help of that only all the processor are controlled. Okay. Next one is a system interconnection and interaction. That is done by means of the connecting wires, or we generally call it as bus. And another things are the types, available type to get the access the data, the address, data, and control signal. With help of these only we are getting and processing, outputting the data. So next, in specific, when you talk about CPU components, it contains registers. First one is register. It is used to hold the data and instructions. As I told, it is the software, and it could be in various size according to the requirement, according to the usage. It will be in various size and various kind of devices. Okay, like RAM, ROM, these things are available. And there are some specific internal hardwares are available. It is handled by the processor, like program counter, memory address register. These are all the internal parts. Normally it cannot be accessed by the general user. And other thing is the control unit. As I told, when you see there, it is the main unit. It is used to control all over the function. There may be more number of hardwares. Okay, each and every hardware can be controlled, processed with the help of control unit only. And as I told, there is the arithmetic and logic unit. It is the main unit in the overall process. With the help of that only, all the data will be processed by means of either arithmetic or logical operations. And this is the main thing. Okay, as I told already, there is a processor. In general way, it is called as microprocessor. Okay, the way it is called as microprocessor is each and every instruction, so that is the software will be executed in terms of microseconds. Okay, so with the help of clock pulse, that is the necessary signal is the clock pulse. With the help of that, the microprocessor will be processed and used effectively. So it takes microseconds to process each and every data step by step that we are writing in terms of instructions or software. Okay, that's why it is called as microprocessor. The processor will do the processing things. Either it can be the arithmetic process or else it can be the logic process. Okay, so that it is called as microprocessor. Of course, for this only we are going to talk about the remaining topic. Okay, how the designing is done for the processor, especially the microprocessor, that we are going to talk about. Okay. So as you see here, to do the arithmetic and logical operations in the arithmetic logical unit, these are the process can be performed. The first one is addition, second one is subtraction, another one is a logical AND. So AND is the general word you could see in dictionary in common English. But here we are talking about a logical AND. This is one kind of process, especially the addition. Multiplication. Logical AND is the multiplication done in terms of binary bits. And logical OR is addition. Okay, binary logical addition it is. Then next one is logical exclusive OR. It is the derived function of and OR. Okay, another one is complement, logical NOT. Okay, complement in the sense if you have 0, its complement is 1. Similar way, if you have 1, its complement is 0. And another logical functions are increment and decrement. If you want to count, there should be two processes. Either it can be increment or decrement. And also it is done by step. That's why the term called add 1, subtract 1 is used here. And another logical operations are left shift. Shift is the general operation, logical operation. The shift can be performed in either way. Either it can be left side or right side. So that here both operations are possible. It is mentioned in terms of left shift and right shift also possible. Okay, it is not mentioning here. However, the right shift also possible. And see that there is a rotational left, rotate right. Okay, so in the shift there will be the end bit will be left over. Okay, but in case of rotation, the left bit again come into the first position, so that it is called as rotate. Okay, there is a little bit difference between the terms called shift and rotate. Another one is clear the instruction. Okay, we call it as generally reset. Okay, that everything will be come to the initial stage. That is called as reset or clear function. So apart from these things, another internal registers are available. It is called as flag. As you see here, the flip-flop, again it is the flag is nothing but register. The register will contain the flip-flop. The flip-flop is set or reset. Set in the sense we are putting 1 in the flip-flop. Reset in the sense we are putting the 0. That the things equal to clear. Okay. So reset equal to 0. So according to the necessity, the things will be happening in terms of set or reset. Okay, it is used to understand whether the program is being executed or it has been completed or it is yet to start. These information will be provided or stored in the flag so that the particular register, particular flip-flop can be accessed to identify by the processor either the processor has been completed or being executed or being started. So these things will be provided by these flag registers. Now come to our major part. Okay, first we talked about computer. In the computer, the one part is called CPU. Okay, in that CPU there is a heart of the thing is processor. Okay, how the processor is made up of, that we are going to discuss it now. So as I told, by means of processor, by using the processor, either you can perform arithmetic operation or logical operation. Everything will be covered in terms of these two operations. Okay. So to do that, certain necessary diagrams, circuits are needed. Okay, that circuit there are two type of circuits, or two major circuits are available in digital logic circuits. With that digital logic circuits only, the microprocessor design has been done. Okay, the two type of design aspects are, one is combinational circuit design, another one is sequential circuit design. Now we are going to cover upon about combinational circuit design. Okay. So this is one kind of circuit. It can be used for both purpose. Okay, even though say we call it as combinational circuit, with the help of that we can do both arithmetic operation as well as logical operation. Okay, so now we want to see how it is happening here. Now you see the diagram here. Okay, so here you can better understand how the usage of the combinational circuit. See this, you can see the motion sensor. If some person is moving in and around that sensor, it can sense, it will provide certain output. Okay, sensor is the device. According to the input, it has to produce certain output. Probably it should be the electrical output so that it can be processed by the nearby electrical system. Okay, here the digital system is mentioned, but it is operated by means of zeros and ones. But that zeros and ones also in depth, when you see, it is operated in terms of certain voltage level. Okay, for example, A can be the value of 0 or 1. Similar way, the B can be 0 or 1. I am talking about logic 0 or logic 1, not the numerical decimal values. I am talking about binary values. So in case of A, if it contains 0 in the sense, okay, 0, logical 0 in the sense, it has the value of 0 volt. Similar way, if it contains 1 in the sense, logical 1 in the sense, it has the voltage level of 5 volt. Okay, this way we have to assume the sensor has been designed accordingly. Okay, so if it observes there is no motion in front of the sensor, the A will have a 0. That is logic 0. There is no voltage will be available. But in case there is a movement in front of the sensor, okay, then it will produce a logical 1, otherwise 5 volt, that can be sensed by the nearby digital system. Similar way, there is a light sensor. If a light is provided in front of the sensor, it will provide the output in logic 1. If there is no light in front of the sensor, it will produce 0 at the output. So these zeros and ones will be observed by the detector. Here we call it as the digital system. So based on that, it will do certain logical or arithmetical process. Then that accordingly the output will be displayed or it can be observed. So here the lamp is provided. For example, if A is 1 or B is 1, either of one is 1, okay, it seems that some desired performance has been done. When that A will have a 1, according to our discussion so far, when there is a motion in front of the sensor, A will assume 1. Similar way, if there is a light source in front of the light sensor, it will have a 1. So either of A or B is 1, F will provide 1. So how this we are going to get? That makes the design of the component or design of the circuit. That we will see in the next stage. See, when you see here, if 1 is provided, the bulb is provided. So when the output is you are getting 1, it has to be observed in some way. Here for understanding the output, we are using the bulb as the output device. When F is 1, okay, when F is 1, the bulb will glow. If F is 0, the bulb will not glow. Okay, whenever either A is 1 or B is 1 or both are 1, at that time it has to provide 1, that is F has to provide 1, accordingly the bulb will be illuminated. Okay, that will be done by means of certain component. When you see here, we have used certain digital circuit with the help of AND gate and NOT gate. See the diagram. So here that AND gate and NOT gate are logic circuits or logical devices. With the help of that logical devices, that is an AND gate and a NOT gate, we have constructed certain logic diagram. With the help of that, we can observe the content what is expected, as I told now. Okay, so this way the designs are happening. Here note that there is no clock is used. Okay, as I told already, as far as any digital system is concerned, there are two varieties. One is combinational circuit, another one is sequential circuit. Here I am talking about combinational circuit. I tell you why it is called as combinational circuit. There is a specific notation is there. When you see here, you understand what is a combinational circuit. Yeah, digital circuits whose output, that is present output, the required seeing present outputs only depend upon the present input only. The present situation, what is the input, accordingly it provides the output. That is the thing, it is there. Okay, so that it is called as combinational circuit. Okay, so to design these kind of circuits, especially the combinational circuits, there is no need of clock. Okay, so that you could see there is no clock here. Okay, so that so it produces with the help of only AND gate and NOT gate, and A and B is having the necessary input. Accordingly, it will process. Then F will be 1. Okay, that how we are going to design. See that the circuit design, A does not contain any other gates like NOT gate, but B contains one NOT gate. Why it is needed? In A it is not there, but B it is provided. Why? So that makes the design of the circuit. Okay, according to our requirement, we have to follow certain procedure, so that you have to use the component available logic gates effectively to have a desired output. That we will see one by one in later stages. You see that is the electrical equivalent. So here the gate can be operated as a switch. The concept of switch, if you understand that, you can understand the operation of the logic gates. Each and every logic gate has its own electrical characteristics. So accordingly, it can be switched on, switched off. Switched on in the sense it provides certain output. Switched off in the sense it will not provide certain output. Okay, that is the thing. Okay, as you know that it is based on electrical terminology. The fundamental electrical law is Ohm's law. V is equal to IR. It is the derived equation. Actually, the statement of Ohm's law says that V proportional to I, or I proportional to V, according to the constant temperature, surrounding temperature of the circuit. Okay, but V is equal to IR is the derived equation. With the help of that, you see that there are three elements: V voltage, I current, R resistance. If one is unknown, other two are known. That you rearrange the equation, you can find the unknown value. That is the application of that. Then you can understand how the function is there. Okay, when you provide a plus minus properly, and if it is connected to the two terminal of the bulb, it will be operated. But if there is a switch is connected, there is no switch here provided by it. But anyway, if a switch is provided in any of the terminal, either positive side or negative side, if the switch is opened, the current will not flow into this circuit, so that the bulb will not glow. Okay, that you can assume that the gate is opened. Okay, the switch, what I am telling, that is put into either of the side of the circuit, that can be compared equally to the operation of the logic gate. Okay, so if the switch is opened, in the sense the logic gate does not provide any output. Okay, in that case, there won't be any output to the bulb, so that the bulb will not glow. But if the switch is closed, okay, so that it seems that the logic gate is operated, it produces 1 as the output. So in that case, the switch can be closed. That way you have to assume. Then the bulb will glow. So that is the concept it is explained here. Okay, now you could see the theoretical concept what I told there. Okay, now you see that one side is source. Of course, the input available to the bulb should be called as a source input. Another side should be called as output side. Okay, now if there is no output from the gate, then the control input will be opened, that is switch is opened, so that it will be opened. The current will not flow from one side to another side. But when you see the next case, source input is connected through output by means of closing the switch. Now the gate is providing path to supply the source input to the output. Now the switch is closed. Now you see certain animation. See that. Now it is opened. Now you see that in the first figure, the current is not allowed out of that switch. But when you see the second diagram, the switch is closed, so that the current is permitted to flow from source input to output side. So it's happening in any kind of logic gates. Okay, that we will see one by one. So mostly there are two type of transistors are available. Okay, one is BJT, bipolar junction transistor. Another one is this one, MOS transistors. Okay, so here we are using MOS transistors. We won't bother about BJT in design of digital system design. Okay, so this is when you see here, I told so many times that we are using gates, AND gate, OR gate, NOT gate. These kind of gates are mainly used in the design of combinational circuits. Okay, so with the help of these fundamental components only, we are designing that digital systems. Okay, so this is one kind of fundamental circuits used in the design of digital component like NAND gate, NOR gate. You see here, it contains three terminals: source, gate, drain. These things are available. Okay, so when you operate properly with the providing supply to the gate, the source will act as the input, the drain will be act as the output. So when the gate is closed properly with the help of necessary voltage, then the current available at the source will be transferred to the drain. Okay, so this is the operation. This is to talk about just a switching operation. You could see there the gate, there is a equivalent circuit of the NMOS. Okay, NMOS in the sense the channel will happen. As I told, there will be the current flow from source to drain. That current flow will happen in terms of electrons, so that the N is used there. Okay, there is another MOS is available, that is called as PMOS. In that the source to drain channel will happen in terms of holes, so that it should be called as PMOS devices. Okay. You could see here, as I told already, when the gate gets 1, here the 1 is nothing but a logical 1. Okay, that we are providing 5 volt. Okay, logic 0 in the sense there is 0 volt, logic 1 in the sense there is 5 volt. Here you see that if 1 is available, the current is permitted to flow from source to drain. The top one is called as source, the bottom one is called as drain. Okay. When 1 is voltage provided, that is 5 volt is provided at the gate, then it will permit the flow of current from source to drain. And you see the second stage, there is 0, that is logic 0, 0 volt is provided. In that it will not permit the current. It seems that electrically the circuit is opened between source and drain. So this is the case. First you should understand this concept effectively, so that you can better understand the concept of gates. Okay. Now as I told, this is another gate is available, PMOS. It is directly opposite to that. In NMOS you have to provide 1 to operate it properly, but in PMOS you have to provide 0 to operate it properly, in the sense that you have to permit the flow of current from source to drain. In the sense you have to provide 0, that is 0 volt is provided, it is to be provided. Okay, so as you know that this is a general concept, so you see that in the first diagram there are though if the necessary building blocks is in unwanted shape or unusable shape, it cannot be used effectively. Okay, it cannot be effectively used. But when you see if you have right components, so that the effective necessary building blocks can be constructed. Okay, so that is the thing it is given. So with the help of transistor only we cannot do anything, but it has to be connected effectively. That even though we talked about NMOS transistor, PMOS transistor, okay, it has to be connected effectively, so that you can have another version, that is N NOT gate, AND gate, OR gate. The first gate is NOT gate, second one is OR gate, third one is AND gate. Okay, so these things are possible with the help of transistor. For that you have to have a certain connections. You need not to worry about it as a user. Designer will do the things, and they will provide the output component in terms of NOT gate, NOR gate, AND gate. Okay, so this is the table. If you want to use, assume that the gate has been fabricated with the help of a PMOS transistor or NMOS transistor. Okay, so now the gates are available. How it will be working is given here. So this is, we call it a truth table. Okay, these are all called as truth table. Okay, so the first one is for AND gate. You see that as I told in the first slide itself, what about A and B? So A may have either 0 or 1. Similar way B can have either 0 or 1. Here we are talking about the binary values. Okay, so with the help of two literals A and B, there are 4 possibilities. 4 different combinations you can have, either 0 0, 0 1, 1 0, 1 1. Okay, if AND gate, if it is assumed as AND gate, for the A is equal to 0, B is equal to 0, the output also 0. And in the last one, when you see A is equal to 1, B is equal to 1, then at that time only the output will be 1 for AND gate. So that you can understand the result. Final conclusion is, at least both are ones, in the sense only that will be the output in proper way, like 1. And when you have a OR gate, similar way, when you go through all the input and output concepts, then you see that if there is at least 1 1, okay, either A or 1 or B is 1, so you can get the output as 1. Okay, so when compared to AND gate, OR gate, according to my illustration in the first slide, okay, if either A is 1 or B is equal to 1 or both are 1, then that should be the F is equal to 1. So that the OR gate is matching with that. So to utilize that operation, you have to have a OR gate. Okay, you have to compare these input and outputs with the concept what we have discussed to illuminate the bulb with the help of sensors. Okay, motion sensors and light sensors. Okay, this is the another one is a simple gate, NOT gate. So it provides a complemented output. Okay, either 0 or 1. If you have 0 in the input, it provides 1 as the output. If you have a 1 in the input, it provides a 0 as the output. Okay. So this is to talk about in simple way. If A is 1 and B is 1, that is we are combining Okay, so for that A and B is 1. Okay, and if you want to either of one, if A should be 1 or B should be 1, in the sense you can go for OR operation. And this is to talk about the combination of these two with the help of NOT gate. Okay, so same thing, that only thing is, as I told already, we talked about NMOS, PMOS transistor. By that I told that it is possible to have a gates. How it is possible, it is illustrated. Okay, you see that if there is a bubble, there is a PMOS device. There is no bubble in the gate, it should be called as NMOS device. You see that there are two devices, both PMOS, NMOS is used to construct NOT gate. There only two gates are needed, two FETs are needed, MOSFETs. Similar way, when you see here, to have a 2 input OR gate, you could see there is 2 PMOS and 2 NMOS. Okay, totally there are 4. With the help of that, you can construct OR. Similar way, the AND gate also constructed with the help of PMOS, for 2 PMOS transistors and 2 NMOS transistors. You see the connections. Okay, how it is happening with the help of transistor, how the connection is happening, that you can understand to have a necessary output. Okay, this is to illustrate the diagram, transient diagram for the each and every component or gates. Okay, it is done in terms of time. Okay, over the time period, how the input is happening. Okay, you see here, this is the pulse, like a square pulse. You can see here better way. Okay, this is the low level will be equal to 0, the high level will be equal to 1. It is logical level, zeros and ones. Okay, so you can understand with the help of that previous slide. Truth table. We call it as that table is called as truth table for the combination circuits. Okay, this is a simple example of how to use AND gate, OR gate and NOT gate. You see this is a practical real-time example. Okay, you see that one person is entering into the car, he is yet to drive or going to drive the car. As per the norms, he should wear the seat belt. It is mandatory. Okay, whether he has wear the seat belt, how it will happen? First, initially he has to open the door, put the key. Then what will happen? He has to sit. First, to open the door, he has to sit on the particular seat and he has to put the key. Then, if seat belt is properly fit in, then only he has to run the car. If it is not happening, that is here the primary priority goes to seat belt. Okay, if he is not wearing the seat belt properly, the alarm should indicate that he is not wearing the seat belt. Now you can see the present cause, the recent cause having this methodology. If you are not wearing the seat belt, it will provide certain alarm warning. If sound will be there. Okay, how it is happening with the help of simple AND gate, OR gate, you can perform it. Okay, you see here, assume that if he has fastened the seat belt, S will be 1. Okay, here 1 is nothing but logic 1. Okay, and K is, if key is inserted properly, K will be 1. If a person sitting on the correct place, the P will be 1. Okay, here the priority is given to seat fastening. If seat fastening has not been done, seat belt is not done properly, then the alarm should switch on. Okay, so we see that how it is happening. So this is the diagram. With the help of simple AND gate, this operation can be performed. Okay, you see that if K is K, what is K? Key inserted. If K inserted is done properly, 1 will be go there. And if what is P? Person sitting in the seat. If he is sitting properly, 1 will be going there. And what about S? If S is 1, when the S will be 1? When the S will be 1. Okay, if he fasten the seat properly, it will be 1. Okay, if he is not fastening, what will happen? What will happen? If S is equal to 1, only in the case if he wear the seat properly. If he is not wearing the belt properly, S will be 0. You see that S is connected to NOT gate. If according to the previous table, if S is equal to 0, what will be the output of NOT gate? It will be 1. Okay, so K is 1, P is 1, but S is not that, it is opposite of the required thing. S is 0 because he is not wearing the seat belt properly. Assume that. Okay, if S is 0, then output will be 1 for NOT gate. Now that is also 1, this is also 1, this is also 1. When you refer the truth table of NOT gate and the AND gate, what happens? If every input is 1, automatically the W will be 1. Okay, so that 1 will eliminate the bulb. If bulb is connected to that, bulb will be eliminated. If it is alarm, then alarm will be ringing. Okay, so when it will be 0, according to referring the previous truth table of the individual component, if AND gate is any one of the input is 0, then automatically the output will be 0. If output is 0, the either alarm or light connected to the W will not be functioning. Okay, when it is possible, he will be sitting properly and he will be inserted. If he wearing the belt also properly, in the sense S will be 1. So this is very important thing. If he wearing the seat belt properly, S will be 1. Okay, if it is S is 1, output will be 0. If any one of the input is 0 for the AND gate, automatically output also 0. So the either the bulb or system will not work. Okay, this is the case. Okay, if he wears the things properly, if done everything properly, then there won't be any intimation to the alarm or light. But if any one of the things is 0, then automatically it will become 0. Okay, we'll stop here. Thank you.